Hello friends, this video on Introduction to Euclid Geometry Part 8 is brought to you by examfear.com. No more fear from exam. As I told that we'll spend a lot of time on the Euclid's fifth postulate. Okay, so let's try to understand some of the equivalent version of the Euclid's fifth postulate. As I told you that fifth postulate is very significant in the history of mathematics. It is the fifth postulate actually which helped in creating a new geometry called non-Euclidean geometry. Right? We will talk about that. So the fifth postulate, as we have seen that there are two lines, there is L and there is M and there is any line. These two angles, angle 1 and angle 2 is less than 180 degree. Then if you extend these lines, it will meet at some point. Correct? So if a straight line is falling on two straight lines, so if there are two straight lines L and N, and let's suppose P is another straight line which is falling on these, and they make the interior angles on the same side, and if you add these interior angles and they are less than 180 degree, then if you extend this line indefinitely on this side, then it will meet, okay, on the side where the angle is less than 180 degree. It also means that there will not be any intersection if the angle sum is 180. For example, if these two lines are parallel, and if you make angle 1 and angle 2, these two are parallel, then angle 1 plus angle 2 is what? 180 degree. Correct? So if it is less than 180 degree, it is meeting, it is equal to 180, that means it won't meet. This is a case of parallel lines. This is a case of non-parallel. So there are so many equivalent versions of fifth postulate. There are so many equivalent versions of fifth postulate. So one of the equivalent version is Playfair axioms. So it was given by Scottish mathematician John Playfair in 1729. If you see, the Euclid fifth postulate was given in 300 BC, and this is in 1729, almost 2000 years after the Euclid gave the fifth postulate. It is also similar to fifth postulate. If you see, it says that for every line L, there is a line L, and for every point P that is not lying on L, there exists a unique line M which is passing through P. So if you see, there can be so many lines which is passing through P, right? So there exists a unique line M that is passing through P, which is parallel to L. There is only one line which is parallel to L and passes through P. Same as the fifth postulate, right? So if you see here, the angle are equal, it is parallel. It means there can be only one line which is parallel to this line which is passing through a point. Fifth postulate, similar to fifth postulate. Okay? And this result can also be stated in following in a different form. It says that two distinct intersecting lines cannot be parallel to the same line. So there are two distinct intersecting lines, let's suppose L and M, and these two cannot be parallel to the same line. So if there is another line, let's suppose Q, so L can be parallel to Q, but M will not be parallel to Q. Correct? So there are two distinct intersecting lines L and M. It cannot be parallel to same line. Let me write here. Two distinct intersecting lines can't be parallel to same line. So there are so many flavors of postulate. Okay. As I told you, the fifth postulate actually helped in creating a new geometry called non-Euclidean geometry. Let's see that. So non-Euclidean geometry. See, Euclidean geometry is valid for figures in the plane, in the curve. In the curved surface, it fails. Right? So Euclidean geometry is valid in the plane. So you see, you talked about cubes, cuboids, all these are planes. But in the curved surface, it fails. And if you see the history of non-Euclidean geometry, it comes from fifth postulate. Fifth postulate is very critical. A lot of mathematicians were convinced that fifth postulate is actually a theorem. They thought that fifth postulate is a theorem which you can actually prove using the first four postulates. Okay. They tried a lot of attempts to prove that this fifth postulate is a theorem. They tried to prove it, but they could not prove it. All the attempts were failed. But these efforts actually led to a great achievements in creation of several other geometries. And these geometries are different from Euclidean geometry, and they are called non-Euclidean geometry. Right? And these were created very recently. And these, the creation of the non-Euclidean geometry created a landmark in the history of thought. Because till now, till 16th, 17th centuries, it was believed that the only geometry form is the Euclidean geometry. But the world itself, you see, is a non-Euclidean. Okay. In fact, the geometry of universe where we live is actually a non-Euclidean geometry. Because world is sphere. It is spherical geometry. Okay, it is spherical. It is non-Euclidean geometry. In the spherical geometry, the lines are not straight. Correct? So if you draw a line from, let's suppose, North Pole, you start drawing a straight line, you reach here to a South Pole. And actually, if you see the line, this is not straight, it's curved. But when you're drawing the line, you'll feel that you're drawing a straight line. Okay? Now, if you see this line here, AN and BN, so these are line perpendicular to AB. So if you see these two, if they are two parallel lines, these two parallel lines will be perpendicular to a line. So let's assume A and B and dash, let's suppose. So in the non-Euclidean geometry, in the Euclidean geometry, there are two parallel lines, they will not meet. Right? These two parallel lines, because these angle is, these sum of the angle is 180 degree. Right? If angle 1 and angle 2, angle 1 plus angle 2 is equal to 180 degree, AN and AN dash are parallel and they won't meet in the Euclidean geometry. But in this case, if you see, these angle, if you add, are 180. Right? So they are supposed to be parallel, but if we extend them, they will meet at this point N. Right? So AN and BN both are perpendicular to this line AB, but they meet each other. Okay? Though the sum of the angles on the same side are 180 degree. So as per fifth postulate, they should not meet. But actually, if you see, these are meeting. And this is non-Euclidean geometry. Thus, we say that the Euclidean geometry is valid only for figures in the planes, and it fails in the curved surface. So we will not discuss non-Euclidean geometry in detail to understand that actually the whole world is Euclidean geometry. But to understand the geometry, it is good to understand the Euclidean concept, because if you see, this is, we are seeing at a larger scale, but at a smaller scale, the world we live in, the land looks like a plane surface. Right? If you see a piece of land, it looks like a plane surface. But all these pieces of land, when combined together, forms Earth. Right? And then it is spherical. The line from here to here, if you draw this, must be 1000 kilometers. It looks like a straight line, but actually these lines, when you end up adding kilometers and kilometers of line, it becomes curved, and that's how the Earth is, spherical. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot.